Our speaker today is Kevlin Henney. Kevlin is a consultant and an author. I won't even try to list all of the different places that he's been published. If you've been following C++, then you've undoubtedly read several of his articles already. He always has interesting things to say, and today he's going to be talking about different styles for using C++.
Okay, thank you, Matt. Okay, it's quite a lot to get through, so I may well skip some slides. We'll see how we go. Play this one by ear. I want to explore some of these questions of programming styles in C++ that tend to pop up. There's a sort of a growing interest in programming styles and the multiplicity of styles available to developers. This seems to be reaching out across languages. There's also a strong recognition that many languages have thrived because they have pushed themselves as supporting many styles in the past. It turns out that some of this interest is not new, but there is also a certain amount of confusion in this space. Not least of which, thanks to our friend, the word paradigm, which has really messed things up properly. I'll have a quick look at that and describe why I favor the word style, but also describe the notion why most languages can claim to support multiple styles. But the focus here is on C++. In the absence of a perfect language, we have a language that is used in production a number of places and has a very strong track record. There are many, many styles that we could be looking at. I have constrained this to just 3 broad groups, 2 of which are properly styles in terms of a way of thinking. The third which was just a bucket placeholder for 2 quite different styles, which I put under the language mechanism. That's the only one defined by language mechanism, as it were, template-based styles. There are many more styles we could be approaching. There are things that I'm not going to cover, and particularly areas where the support is not core in the language, or the support is not there in the language at all. You can sort of fake up a functional programming style, sort of, kind of, but it's never going to be the same as using Scheme or Haskell. That's not a style that is supported. If we talk about concurrency, there are so many overwhelmingly different styles of concurrent programming, and strictly speaking, none of them are supported in standard C++, although we have ways of wrapping things and doing things. The most pervasive style here is a sort of standard free threading style, which kind of fits out as an offshoot of procedural. Again, I'm not going to talk about that one because certainly in itself it's a talk. I'm going to presume that you've got some kind of idea of programming for a start. I want to get a sense of how many of you use C++, either sort of 20% or more of your time is taken up. Okay, so there's something. Okay, that's reasonable. Okay, that's good. So that'll allow me to shoot past a lot of slides, just going, yeah, you know this. I want to, first of all, look at this question of styles. Conveniently enough, there is a word that covers what I'm interested in. Stylistics, the study of the literary styles of particular genres or writers. This captures probably a little more closely the way that we look at and work with different approaches to programming than the common use of the word paradigm. Trouble with paradigm. Paradigm is a term from linguistics, so surely it should apply to programming. Well, not really. That's not how it's used. The sense in which people have kind of tried to use it was popularized by Thomas Kuhn in his 1962 book, I think, related to the structure of scientific revolutions, a book that I won't say is riveting reading, but I will actually claim to have read it. I got something from that many years ago. And that was what defines the modern use of the term. Now, what is interesting is that even there, you'd think, well, that's it. There's a concrete, solid definition. But even then, that doesn't work. Many people, when they look at it from the kind of Kuhnian sense, are trying to say that there's one way of doing things, that there's one kind of dominant and overarching way of doing things. Now, in programming, this has never really been the case. The world of programming is diverse, and one area where people are programming may be completely disjoint to another area. You get a COBOL programmer talking to an APL programmer going back a few decades. No, unlikely. They do not have a common language or even a common way of speaking. That has not changed. There has never been a single overarching model. There may be something that we teach a lot. There may be something that is in the press and is in vogue and is sexy, but there's never been one single way of doing things. The other way in which people use it is they try and use it, based on the first point, they try and use it to make a marketing point. And it's related to the term paradigm shift, and that notion of shift happens. The idea is, well, we were all doing this, but now it's all going to be different. We're all going to be doing that. That's mostly for dramatic effect or to make yourself just sound a little bit clever. You know, there's another way of doing something. Probably more usefully, sometimes people try and relate it to language features. And again, that's a very mechanistic way of looking at it. I don't enjoy looking at languages just purely from a point of view of mechanism. It's how the mechanisms interplay. So, for example, being able to overload functions is not a paradigm, although I know that I've seen that claimed in a book. Perhaps the most useful one, and the one where it was originally used with great effect, so 1978 Turing Award winner, whose name has just escaped my mind just at the moment, and he wrote the paper. Oh, Robert Floyd, there it is. He wrote a paper where he effectively used paradigm to mean pattern or architectural style, if we use more modern vocabulary. And what is interesting is that he related this to what many people try and use the branding multi-paradigm for. Now, if paradigm makes you try and sound smart, then multi-paradigm is designed to make you sound really smart. Again, so we already have confusion over the term paradigm. Multi-paradigm just multiplies the confusion. Sometimes it's a set of language features. The challenge here is that if you're saying that a paradigm is related to a style or a pattern, then clearly a single paradigm approach is a failure mode. If you only have one way of doing something, then that is a problem. So by definition, anything that is multi-paradigm is normal. Single paradigm is a lack of imagination and ability. A programming language that is general purpose is by definition multi-paradigm. I know of very few general purpose programming, well, in fact, I know of no general purpose programming languages that could ever be said to fulfill only one paradigm. And part of the problem with this is that the term paradigm is not a normalized term. It's not disjoint. You don't have this mutually exclusive with that. You look at things, you see them at different levels, overlap, and all the rest of it. Not a useful term, too much confusion, let's use something else. Focusing on style. From the dictionary, we can see that it talks about the notion of style, a manner in which something is done, a distinctive appearance and design. If we start looking at building architecture and talk about building styles or the sort of schools of design that exist, that gets us a little bit closer to what we're talking about. And there is no notion that we only have one way of doing something. These are all complementary, they can coexist, and indeed that's the normal state of being. There is nothing modern about it, there is certainly nothing postmodern about it, although that is a term that seems to be gaining some popularity in certain quarters. So what we can say is that individuals have styles, a lovely little word that's not commonly used, idiolect. The problem is that idiolectic style is problematic. I'm sure you've all encountered code that falls into this category. Oh, yeah, that's the way he codes. Very particular way of doing it. The school of thought establishes an idiom, so a group kind of approach. But even when we say procedural style, that doesn't tell you that there is one way to do something. If you get a C++ programmer using a procedural style, I ask you what that has in common with a Fortran programmer using a procedural style. Having been a Fortran programmer, I can tell you these are worlds apart. Having gone from Fortran to C, I recognize that all of my C code initially looked like Ctran. C spoken with a very heavy Fortran accent. It was unrecognizable as proper C. It was syntactically correct. When I did Fortran again a year later, my Fortran was unrecognizable to a Fortran programmer, and that was one of the first things my colleague changed. So to even say procedural style doesn't nail it down. Each language pretty much comes with its own notion. Now, of course, any real problem is going to demand a little bit more imagination. The idea that if you only, there's nothing more dangerous than an idea if you have only one idea. So you are expecting in a serious piece of software to mix styles at different levels in some way. Some of it may be individual preference, but in other cases we'd like to think that it's anchored in the problem. The challenge here is that when people mixed styles, it does take skill and taste. These are two things that are not necessarily easy to teach, but can be acquired over time. And obviously, there's a certain sense of subjectivity to taste, but there is some intersubjective agreement. And when people often use this notion of mixing styles, and sometimes I've heard people sort of say, yeah, we're doing multi-paradigm development. What that actually means is we haven't got a clue what we're doing. We're doing all kinds of different things. It all kind of fits together. The other branding for this is postmodern. Again, I'm not interested in that. What I think a lot of these approaches are missing is a focus on the problem domain. What a crazy idea. These are all solution styles. There is somehow, hopefully, a relationship between the style that you choose for your solution and the nature of the problem that you are solving. If you are solving a process control problem and you are bickering over whether procedural versus object-oriented is the right way to look at it, you are looking in the wrong place. Neither of these styles is the dominant architecture of a process control system. Okay, they has aspects of both. Both of these styles can be incorporated at a more tactical level. In other words, it's the wrong discussion. In other words, what is the problem? And again, a crazy idea. The notion that we would like to relate the problem to the solution is something that has a very strong resonance with patterns, which is something that I'm very interested in and have a reasonably long track record with. But also other ideas, problem frames that relate to the work of Michael Jackson. You are invited to guess which Michael Jackson it is. You have a number of choices. You can pick from a menu of 4. There is Michael Jackson, the beer hunter, who sadly died last year, but go to beerhunter.com. Author of some very good books on beer and whiskey from around the world. Good Christmas presents, these books as well. There is Sir Michael Jackson, who's the head of the British Army and headed the UN force in Kosovo. It's not him. And there's Michael Jackson, the methodologist. Ooh, that sounds promising. And then there's the other one. We can skip that one. Now, Michael Jackson, the methodologist and requirements guy, focuses extensively on this idea that there are different kinds of problem that require different kinds of description. Okay? And there are characteristic things that tell you about the kind of problem it is. And that will lend itself to suggesting a way of solving the problem and an appropriate style. And Robert Floyd, in his paper on paradigms of programming, which I want to point out again, goes back 30 years, he made the point that one of the challenges that we have in programming is that we don't have enough paradigms, using his term. We do not have a sufficient stock to address the actual problems. We have a narrow, limited vocabulary. That was his perspective. So if we go and look at something like C++, there are a number of things that it's quite good at and aligns very well with. If we're going to do this kind of idea of aligning problem and solution domains, then when you have to talk to the machine and you care about things that are machine level abstractions, then you want that level of control. There's a kind of an essence of control freakery to the language. Yeah, this is not a language for people who like to drive in automatic. You need a manual gear shift, okay? But once you've got that, boy, you can use it. So if you like that, then it will fit. So there's a personal fit as well. But in many other respects, we're talking about where it fits in the world of the things we want to build. Embedded systems, there's a good fit there. Real-time systems, you have that kind of level of accuracy. If you look at languages that have been general purpose but not designed for these, and for example, if you look at something like real-time uses of Java, you practically have to gut the language and all of the big selling points in order to get it to work in that environment. Whereas C++ requires relatively little adaptation from that point of view, almost none. It depends on the kind of systems we're talking about. High-performance computing, systems programming in general, algorithmically focused code. I find that if I have to write algorithmically focused code, certain frameworks are pleasing and easy to use in Java. If I write algorithmic code in Java, I don't know if I get... it's difficult to describe, but the experience is boring. The experience is one of tedium. I enjoy certain other activities in Java, but algorithmically focused code is just tedious to write. It doesn't support the right level of mechanisms, although ostensibly it has a common heritage. Games programming, nice exciting one there, and obviously many other domains where C has been favored in the past. These are the core areas. Although C++ has a certain reputation as being a general purpose application language, we're kind of seeing that one drop off, and I'm not actually too sad about that, to be honest. Having been involved in training and consultancy for a number of years, I'm quite happy that there are a bunch of people out there not using C++ for that purpose. It's making my life a little bit easier. So there are other areas where C++ doesn't really fit. Some of that's from its own design. Some of it comes from its history. Some of it comes from problems with library design and cultures of library design. C++ has suffered a diversity and enjoyed a diversity of different library approaches, but some areas just never really took off the way they could have done, or indeed there are other ways of solving these things. And I'm thinking particularly here, it's not that you can't do any of these things, it's just that when you actually realize, when you work backwards from what you'd like, it doesn't look like the C++ code. It's doable. Of course it's doable. Ultimately, anything is doable given a computer. We're smart people. It just might take a bit longer to do it in assembler, okay? But it's all achievable. That's not what we're after. It's effectiveness. So I'm going to have a quick look at procedural styles. So it seems appropriate to pick a nice little algorithm to start off with. It's one of my favorite algorithms. It's not encapsulated in the STL. And it actually, it's quite a good process for sort of software development in the small, though difficult to replicate. And normally, unless you're a Nobel laureate or Turing Award winner, maybe you want to put a step 4 in, check it. Yeah. So what do we mean by procedural programming? This notion of a hierarchical decomposition of tasks. Okay, it's about the things that we do. The things that we do it with tend to be slightly more subordinated. They're more passive entities. We look at things flowing through this. In this sense, where the notion of the data structure is considered more passive, there's some degree of commonality with functional programming, because the idea there is your primary construct is a thing that does something or transforms something. The data flows through the system. And this is reflected in the styles of analysis thinking that grew out of this school of thinking, data flow-based approaches. This is all very much at that level. The dominant element is the thing that we are doing. Let us decompose the thing that we are doing. Now, we have a number of choices. The classic view of procedural programming is very much the top-down view, the structured programming view. I'm a little reserved about using the term structured programming. Has anybody actually looked at the book called Structured Programming that was written in 1974 by Dijkstra, Hoare, and Dahl? Because in that, you'll actually find that what we call object orientation is quite cheerfully listed as the third section. So, because it is programming with structure. So structured programming as a term of differentiation, I'm not entirely sure it's the right one, but nonetheless, people often use it in this way. There are differences even within this basic space. A notion that is often overlooked is there is a fundamentally different style between more algorithmic and process-based code. For example, there is actually a technical difference between a procedure and an algorithm. An algorithm, you wait for it to terminate, because it's supposed to terminate. That is what characterizes it. A procedure is not necessarily going to terminate and leads us into the world of processes, and indeed there's a whole different style out there which we're not going to touch today. But nonetheless, if you wait for an interactive system that is written in a procedural style, or indeed any style, if you wait for an interactive system that characterizes process and processing, if you wait for that to terminate, you will be disappointed. You cannot say the post-condition of this action is, because there is no post-condition. Post-condition is system shutdown. So there's a very different style of expressing these. There's the algorithmics view, which offers you one frame of thinking, and there is a process view that offers you a different fit. So even within procedural style, there is a reason that this section is called procedural styles plural, because there is more than one. Again, when we look at things like event-driven systems, I'm trying to characterize it by the nature of the problem and the architecture. We can use procedural styles. What we end up with is an inversion of control flow. Function pointers, C++ support this well. Member function pointers supported up to a point. A little better off when we start using some of the newer library features. It's not something that you get out of the box in C++ in terms of the core language, but the notion of being able to bind a context of execution together with the target of execution and the action, then that's quite nice. That's very pleasant. There's a number of features in the TR1 library originating from Boost and making their way into the C++ Xerox or 0x standard, which may or may not be hexadecimal. We're not sure. That value of x. It's kind of touch and go, as I understand it. But although we have used this, I mean, if you think about a lot of windowing code, it's clearly event-driven. Use of callbacks and these approaches fits here. I will say event-driven systems also fit with OO, but I've got other things to say on OO, so I won't be revisiting that topic. But in truth, there's good support here, but there is a very large hole. From my point of view, having worked with a number of other sort of languages and contexts, the lack of metadata and reflection means you can't support a style of architecture known as implicit invocation. Has anybody here ever used awk? OK, a few hands go up. There's a big difference. And if any of those people use Perl? Yeah, OK. Yeah, Perl. I never really kind of got on with Perl. I thought that awk had a certain elegance to its design, and it has this kind of implicit invocation approach. Perl is kind of executable line noise, very, very strongly kind of top-down procedural in its approach. What was nice about awk is that you would say, right, this is a language that is structured for the execution of matching regular expressions on input, on a sequence of input. It's a sequence of transformation. It fits within a particular architectural model, and it does so very well. And when does this piece of code get executed? Well, when it matches this. You have the notion of a rule or a trigger, and it implicitly matches. There's no if it matches this, then do this. It just is. The structure of the program is characteristically defined like this. Now, this is a style that if you have a language that supports metadata reflection and indeed an element of metaprogramming, you can get quite a lot out of. And there's a lot of Ruby frameworks out there that demonstrate the power of this approach. And a lot of the modern Java architectures that are perceived as being lightweight in approach rely on the use of annotations that just allow you to mark up a class. You can actually do this. It's a good exercise if you're thinking of something interesting to do. Create an awk-like framework that allows you to take a class and annotate all the regular expressions you'd like a particular method to execute on. And it just is. It's very, very simple. There's no registration process. There's no if-else if. It's a very different style. This is a hole in C++. Now, what I'd like to do is take that event-driven style or event-driven problem and do something with it. And I want to demonstrate some different styles. Timer on off. So you have heating. Well, no, you don't. You're in California. But I'm from the UK. We have heating. It gets cold. You need to turn the heating on. You need to turn the heating off. And rather than doing it manually, you'd like to have this on a timer. That makes certain sense. So we have our heating class, and we can turn it on and turn it off. If you favor a flag-driven approach to programming, you would have enable bool true false. But let's actually use this kind of sensible kind of style of programming, an intentional one where we say turn it on, turn it off. And we've got a timer, and we choose our time of day. And we initialize that, and we have the notion of being able to run it and cancel it. The one I'm interested in, though, is this. There is something I would like to do. I would like to turn that on at one time of day and turn it off at another time of day. What goes in the gap? OK, so here is a C-style approach. The C-style, it has a certain elegance to it in terms of its brevity. It is short. It is very sweet. You have two functions that are based on the task. I would like to turn this on. I would like to turn this off. It's a very simple view at that level. And then we have, then it kind of goes a little bit messy. Void pointers. OK, so C++ is a statically typed language. And this works for an awful lot of cases. But when you really need to sort of start getting general with certain things, start messing about with the bytes, then you need void pointers. The other reason that void pointers are often used is genericity. I don't want to confuse that with genericity of templates, but it is that general purposeness. It's that how you get generics in C, as it were. You tell the compiler in no uncertain terms, thanks for your help, OK? But I'll take it from here. Trust me on this. OK? That's what you're doing. Now, obviously, it's a trust-based game. Trust the programmer. It is one of the notions, the spirit of C that we have in C++. But there is another aspect to this. I mean, it's difficult to call that code there and this code here pretty. It's quite ugly. OK? This is messy. You've got a lot of issues going on here. You've got a correlation as well. And this is one of the challenges, is that there is as it were, an unnormalized correlation. What I mean by that is that the thing you pass in here or the thing you pass in here are correlated with one another. But you've just told the type system, don't worry about it. The type of that depends on what you're passing in here. You better agree. Now, what is missing here is this correlation. Now, when we look at this from an object-oriented point of view, we have a name for a thing. It's called an object. You know, the way these things are always kind of together, and we'd like them to be together in a meaningful way, that's a thing. So, classic OO solution is to use the command pattern. Now, this tends to be, so this will work, as indeed will the previous one, but this has required a certain expansion in the amount of code. We've introduced a command. We've got a pure virtual function. It effectively represents an interface. Our timer is at least simple. So, we've shifted the complexity over to this stuff. You see, the top line represents a contract that's quite straightforward. It's this stuff where we're getting the accidental complexity, the complexity we introduce to the problem in solving it. Okay, that's just the kind of the noise. That's the overhead you have to pay to get this working. And we've got things like the heating pointer and all kinds of other things. And then it'll do the right thing. So, type safe. It is correct. It's not as direct as it could be, though. So, if we return to proceduralism, but we look at it from a modern C++ point of view, using either boost function or tr1 function or C++ 0x function, there is a nice little function wrapper. It is the idea of saying, well, a function, we can use an object in a tactical sense, and it wraps it up. It wraps it up. It contains the polymorphism, which we'll talk about in the next section. And now, I've actually got everything wrapped up there. It's quite nice because this is the only bit of code I'm actually showing where it actually shows you how it's set up. So we've got a timer. I'm going to turn it on. Here's when it goes on. We're going to bind the operation to turn it on against the system. We're going to turn it off when it goes off. We're going to bind the off operation with the system, and then we're going to say run, and that's it. So there's a certain directness. This is still procedural code. Okay, that we have not introduced. We are using objects in a relatively tactical sense, but the overriding style is that of proceduralism, but it's done in a style that fits what we're working with. Now, object-oriented styles. Then again, this is where the plural really matters. There's quite a few procedural styles, but the plural really matters when it comes to object orientation. When people talk about the object-oriented style versus the procedural style, or the object-oriented paradigm versus the procedural paradigm, that glosses over a remarkable number of differences of perception. With object-oriented programming, there are some elements that are common to lots of different object models. You are partitioning the development and indeed the runtime into units. And the development is partitioned into classes characteristically. That's the typical one. That's the paradigm of object-oriented programming. Another use of the word paradigm, example. Yeah, not a good word to use. This is the common example. There are other object models that don't use classes. And it's runtime to objects. So you have this notion of characterizing objects in terms of identity, state, and behavior. For different objects, these weigh up in different ways. So some objects are stateless, some objects the identity is irrelevant, in other objects the behavior is trivial, but the state matters. There's this kind of shift and interplay between these three aspects. So you have this kind of structure. The kind of formal way of characterizing, it's normally seen as the rule of, or the kind of the three things, the three columns of object orientation: encapsulation, polymorphism, and inheritance. But if you want to be a little more precise, it's runtime polymorphism, and it's a form of polymorphism that is called inclusion polymorphism. There are three other types of polymorphism: parametric, coercion, and overload-based polymorphism. C++ does have the benefit of supporting all four of these. It's one of the few languages to do so. So if we're looking at paradigm meaning programming features and mechanisms, then actually it's quite rich in this respect. But as I say, this is only scratching the surface. Here is some sort of space of diversity. You've got the statically typed school, and you've got the dynamically typed school. When you try and get these people talking to each other, they have very little to say except abuse. Okay? There are the experience of programming in Smalltalk, the experience of programming in Ruby is fundamentally different to the experience of programming in C++. These are very different. So people would struggle to recognize these as being the same kind of object-oriented thinking. Although people pushed this a lot 15 years ago. Oh, yeah, Smalltalk and C++ and Objective-C, and there were a number of other languages that were popping around. The notion is that they are actually really rather different. They share some common elements, but it's like, you know, COBOL and Fortran, they're both procedural and they're from the 1960s. Well, they must share a lot in common. Well, yeah. IBM? Yeah, that's about it. They are very different in their outlook. So in statically typed models, inheritance is normally used one of the main reasons you use inheritance is to introduce polymorphism. In dynamically typed languages, you don't need it for that. The only reason you use inheritance is for subclassing as opposed to subtyping. It's a very strong distinction. In statically typed languages, there may or may not be support for reflection. This is something that C++ misses. It eliminates a whole class of things that you can do. But of course, we have support for other things that we can do. But it does characterize the fact that this object orientation is kind of different to that object orientation in very fundamental ways. There's object-based programming. Object-based is often referred to in terms of just being kind of encapsulation or classic ADT. The only kind of polymorphism you're really thinking about is link time or compile time polymorphism. There's no real sense that you're dealing with runtime substitution of anything. That's not really the game. Inheritance is not a player in this space. C++ has decent support for that. And then we have things like prototype-based approaches, which I guess these days characterized in it, or can be seen in things like JavaScript. There is no real concept of class. Again, that's an object model, but not one that is supported out of the box in C++. And if you do try and support it, it looks a bit strange. People look at you funny for doing it. So we have a number of things. You have the data privacy concept in C++. We have a private keyword, but it's not as private as you'd like it to be. We have to recognize that. There are techniques for decoupling C++ code further, but coupling is one of the dominant forces that will shape or hinder a large system in this style. But that does have an influence. We are missing a number of dynamic facilities in the language, which is a pain in the backside, to be honest. The fact that there's no reflection and there's going to be no reflection in a standard way does limit certain options. But again, the presence of virtual functions and standardized function adapters is very useful for a number of other things. And object-based programming, very well supported indeed. The non-inheritance view, why would this be useful? Classically, value-based programming is the area where this takes off. This is a sort of this is again in the object-oriented family. Well, it blends nicely into the generic programming family we'll look at in a moment. Now, object lifecycle management tends to be the challenge that people have. And sometimes people look at the world, again, in black and white, and this side versus that side, and it's all about GC versus explicit memory management. That's not necessarily the right way to look at it. There are four fundamental ways of organizing lifetimes. Explicit management. You choose when you get rid of an object. And you do so explicitly. I would like it at this point in the code here. And that is decoupled from the point at which it is created. Okay? It just has to come after it. Before doesn't work, and twice definitely doesn't work. And never's a bad idea as well. Okay? These are classic failure modes. Scope bound. This is the simplest of all the models. It is automatic, so non-manual. It is deterministic, like explicit, but it is deterministic. You scope the life of an object within the life of another thing. That thing may be a bounded scope, a function scope, or it may be the scope, as it were, the lifetime of another object. My gut instinct is if you can organize as much of your code as possible using number 2, that eliminates a large class of hassle that people encounter. But if you are used to creating your objects dynamically, and that is your favored style, then you will find yourself dealing with the problems of number 1. It's not that you can't do it, it's just sometimes a bit challenging if you make everything a pointer that needs to be managed with a delete. Then we have reference counted. Now, 1 and 2 are kind of supported out of the box with C++. The third one is a library addition. This is something that you have to do yourself, or you get from the box shared pointer. So it's not supported out of the box. There are limitations to it. More are becoming apparent over time. I think it is a very effective technique for the problems that it solves, but I find people sometimes try to solve too much with it. There are performance costs to this. There are architectural costs to it. It's a relatively intrusive approach, and there is a certain fear sometimes of smart pointer madness. And they're not always smart. There is a kind of like, yeah, just use it because you're not sure about something. Use a smart pointer to do this. However, that is something that we can support within the language, and it does have applicability. It can be effective. And then we have garbage collected. Now, this one's outside the realm of standard C++. And there's a lot of discussion and debate about how best to support it. Garbage collection these days is not the same as garbage collection was 20 years ago, 40 years ago. As we move to increasingly concurrent models of programming, incremental, as opposed to stop-the-world garbage collectors, have a big win for certain kinds of architecture. And this is it'll be a shame if we're not able to support this in a standard way. Now, let's have a look at some of the styles within this broad family of styles. Inheritance-based approaches, inheritance-based thinking. This is where many people are first introduced to object orientation, and where they first get to grips with having gone beyond the basic class, their object-based approach in C++. They are then introduced to inheritance. Now, there's a certain syntactic overhead to doing this. The default that you expect is not the default that you get. But once you've got your head round :public, and here's the thing I'm inheriting from, the normal emphasis is on being able to compose with respect to code. The idea of organizing classification as being a way of organizing the commonality of your code, to avoid duplication, to avoid the joy of copy and paste, and maybe reduce your macro count a little bit. You know, these are all the ideas that this supports. So there is a case here for inheritance-based programming. You end up with kind of style and approach kind of like this. You end up with at least with disciplined use, you can end up with a kind of class hierarchy where you support infrastructure basic facilities, you build on its services, then you have your problem domain, your application space, and you kind of compose it at this level. So it's a composition technique for dealing with code primarily. But I would actually say that this whole approach, even though it's the one that people are often taught, it is the one that was touted, reuse and all the rest of it, there really is no such thing as reuse the way that people describe it. Reuse is an accidental property of anything. It's difficult to plan for it. What most people mean when they talk about reuse is use. It's a far less attractive and exciting term. When you use a library, you are using it for what it was intended for, normally. You are not reusing it unless you're doing something really crazy with it. So in that sense, reuse in the real world is about repurposing things. I can reuse these seats here and rearrange them to form a bed. Not a very comfortable bed, but I can do that. That's not their primary use. I'm reusing them outside their original domain of applicability. What we have here is the notion that what people are trying to do when they talk about reuse is create commodity, which is a very different thing. So tomorrow I will fly back to the UK. I will not reuse the plane. I will just use it for the purpose it was intended. There's nothing fancy or exciting about that. So this is the kind of the attraction that people have often ended up with. And it is a very intrusive approach. It is sometimes based on coincidental opportunities, but it does introduce a very strong form of coupling. And in C++, that coupling is amplified through the fact that it involves the source code structure. So we need to be keenly aware of that. But regardless of that, there is this kind of inheritance-based approach, or inheritance-first approach, has fallen strongly out of favor. In terms of interface-based programming. Interface-based programming, which we could look at from the other side as being part and parcel of component-based programming, is where we focus and we make a strict separation of the way you use something, the usage type, the interface to it, from the way that it is built and implemented, the underlying concrete class or creation type. That we make a strict separation, not just a kind of we'll put some of the implementation details down in the hierarchy. No, a really strict separation. We can do this relatively easily in C++. This is not a problem. There has been a growing trend towards using flatter class hierarchies that are wholly abstract at the top, moving away from the style where we try and accumulate implementation. It turns out that the challenge is not to write code, the challenge is to organize code. This offers us a more meaningful way of working with things. You end up with the equivalent code, and actually these two these two diagrams are taken from a couple of real projects. The before and after, we took inheritance-based code that was tightly coupled, that was difficult to test, and we teased it apart, retaining the broad layering structure, but making a strict separation between the concept of the thing that we were dealing with and the realization possibilities. The amount of executable code remains the same. It's conserved. The amount of declarative code does go up a little bit. You have more constructs. But the amount of stuff, actually doing stuff, remains consistent. This is far more extensible. It also emphasizes something different. If you go back to this one, there's an intentional, there's two intentional points to the titles. This is infrastructure plus services plus domain. This is domain times services times infrastructure. This is domain-centered from the point of view of people who are working with the application. This is what they see. They don't have the weight of the infrastructure pushing down on them. And having seen developers struggling with the fact they're getting all these arbitrary dependencies through, struggling to deal with those from a testing point of view, this makes a difference. They want to see application concepts and have their code integrated in a more plug-in style. That's one of the things that interface-based approaches support very nicely. The other notion is the freedom of combination, the flexibility, the degrees of freedom. This is a plug-in-based approach. You're not hardwiring assumptions. Inheritance is a very strong relationship. This is about composition. It's not that nobody thought the composition would be a good idea. It's just that this style of programming naturally encourages it. We can actually see there's a spectrum. I don't want to suggest that these are two mutually exclusive approaches. There is a spectrum from the inheritance or subclassing-based approach to a more subtyping and interface-based approach. General thinking moves this way. But we do have some challenges. These are the benefits: parallel development, testing, component deployment, plugin style, and so on. But it shouldn't make a difference, but it does. The lack of a specific construct in C++ for doing this means a lot of people miss it. A lot of people miss it as an opportunity. It requires more ritual and ceremony as well as adherence to an idiomatic style. If I'm working in C# or Java, I just go interface, whatever, open curly, things I care about. With semicolons, I don't have to worry about putting abstract or anything like that in, close curly, and we are done. In C++, there is a certain ritual and ceremony that I have to go through. It's still called class. Then I have to argue with my colleagues over whether or not I'm going to put an I in front of it. I must admit, I've never been particularly fond of this approach because it makes everything bunch up in the wrong place of the alphabet. You know, I came, I saw, I conquered. No, this is not interesting to us. Okay? And that I don't find a particularly effective style. Even worse is where you see companies where they've got I such and such, and then you look at it and you say, yeah, but it's got implementation code in it. Oh, yeah, it started out an interface, but we couldn't change the name. Yeah, this is a piece of code that is lying to you. It's a convention that is not as useful as people think it is. However, once I've got past that argument, then I go open curly, public, virtual. OK, I'm OK with the virtual. Blah, 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 equals 0, semicolon. Oh, what are we going to do with the destructor? Do we make that, that's going to be pure virtual or not? Oh, but I still have to provide a definition. I can make it protected if I don't want people to. There's lots of little fascinating decisions we can go through. That means there's a little bit of accidental complexity there. I've not found it to be a problem, personally, but I do recognize that it is a problem for many people. A lot of people just don't get it. They don't adhere to the convention. They don't understand what the implications are in the long term of actually keeping to the style, because you're actually telling people to not write code. People are paid to write code, so they feel a little bit uncomfortable. Maybe I could put a little bit of helpful default stuff in there. You know, I'll be just helpful. Programs are terribly helpful to people, but this is actually a disadvantage. If you've got helpful stuff, put it the next layer down. Keep the top clean. There are very good reasons for doing this, and there are a number of techniques that buffer and allow you to change the elements of the hierarchy and maintain that crisp idea of that is just the way you program to it. What is interesting is that in spite of the fact that people do struggle with this in C++, when they do it, it turns out to be very effective. A team that I've consulted for over many years told me that this was one of the most useful, or no, this was the most useful thing I ever told them. The possible implication of that is that nothing else I told them was of any use at all. That's fine. You know, getting one hit is good, at least. But the notion here is that there is a style that we are potentially overlooking. We also have this notion of a lack of proper modules, the other side of the interface, actually having a formal unit of composition for the implementation code and making a very clear notion about that, naming it, having a concept of dynamic loading that is portable. Doesn't mean we can't do it. It does mean that we have to be careful when we support different platforms, shared objects on Linux, DLLs on Microsoft Windows, very different semantics between these. But nonetheless, there are possibilities here, but they are largely overlooked because it doesn't look like you're doing much. That makes people feel uncomfortable. Value-based programming, I indicated before, is one of these areas that C++ does have very good support for. The idea of, now again, this is not a single all-encompassing idea. This is just a category of dealing with objects, and they are well represented in C++. The idea of values is that they are fine-grained objects that are strongly informational. Their identity is of very little interest. And they typically reflect on objects in the real world that have these properties, money, dates, and so on. Depending on your domain, these are either values or entities of interest. But there are particular styles here. You don't really worry about dynamic memory. These are things that you can copy around quite freely, and therefore copying transparency can be useful, passing by const reference, all of these things. This is relatively well understood, even if people don't describe it in these terms. The next standard will provide better opportunities for optimizing this kind of code, being able to move values, relevant when we're dealing with value objects that do internally manage their own memory allocation. It just gets rid of a little bit of potential waste when you end up with all of these spare copies floating around. However, some of the details appear to be quite subtle, and I'm dreading the prospect of actually having to teach some of this stuff that's going to come up in the next standard. This is kind of a little bit expert-friendly. It is powerful. If you know what you want from it, you can do an awful lot with it. But I am a little bit concerned at this point of what the accidental complexity is. I don't have enough experience with it to really comment. But it does seem interesting that most of the people focusing on it are people I regard as C++ experts. So, general object-oriented issues. Not everything fits this worldview. OK, that's acceptable. Some of that comes about because C++ does not necessarily have a unified type system. That in some languages, there is a unification of the idea of an object and a function, and there is no contradiction seen between these two. We can do this through adaptation in C++, but it requires adaptation as opposed to being out of the box. But once you've got it up and running, and once it becomes the culture of a particular project, then it can be very effective. But the other aspect is to be keenly aware that C++ is one of many possible worlds. This is the kind of the many worlds theory of objects, if you like. Now, final family of styles, well, they're not really family. It's two different styles that I'm going to look at that are actually unified just because of the mechanism that we use to express them in C++. It's more coincidence than anything else. There is no such thing as a template paradigm. There is no such thing. It is a language mechanism that can be used for good, for evil, for obfuscation, for clarity, whatever. So let's have a look. Generic programming is the one. The name is unfortunate, and this has been recognized by Alex Stepanov and others, that generic programming is not really the right term because it makes it sound like it's generics. This is a style that is focused on algorithms. It is a style that is general in its outlook. That is the emphasis. In C++, we tend to build on compile-time polymorphism and value-based programming. In other words, templates, overloading, conversions, copying, and encapsulated memory management. These are all the key features here. As a style, well, I'm going to skip this slide because we're getting close to the end. It's got a lot going for it, but I would say that it seems to be one I've not seen any applications that have this as their dominant structuring principle. And I'm talking about significant large-scale applications. I'm happy to see some, but most of the time I see this, it tends to be a tactical approach. We have some interesting stuff coming up in C++ as Xerox Concepts, and I believe Doug Greger has already given a talk here at some point in the past on that. So again, I'm going to skip that. Let's just have a little look at a nice, simple fragment, and then wrap up. This is a little example based on some code from TR1. Random number generators, certain elements of style if you're using lots of templates. Remember, typedef is your friend, often overlooked. This notion of loop-free programming, the idea of being able to compose in one place, something, as I said, reminiscent of functional programming here, being able to compose in one place, something that is centered around an algorithm of some kind and uses objects at best in a tactical fashion. The dominant idea here is the thing you want to do. OK, now, mixing styles. I'm going to kind of skip that. I want to kind of briefly talk about template metaprogramming. Anybody come across that? Lots of angle brackets, kind of scary. Whoa, look at that. That's fantastic. OK, the challenge here is that C++ doesn't really support metaprogramming in the general sense. It only supports a particular compile time approach. It can be used for some very, very useful things, some really keen observations, optimizations. But what I would like to emphasize here is that its a domain of applicability is not for every programmer. It is not the kind of thing you'd use like an if. It's not the kind of tool that you sort of say, yeah, I use that every day. If you do, you have to be doing either really know what you're doing or not in this case. You can spot the template metaprogramming code, can't you? It's this stuff over here. I do urge you to look at your code by doing this technique of zooming right out and reducing the point size to something little. People do it with helicopters, and they find the lines of ancient fields still in the ground from thousands of years ago. You can do this with code and see characteristics from the air. That's the template metaprogramming. This is a piece of code that turned into this piece of code. There's no template metaprogramming here. There's just overloading a couple of objects. That's it. And the notion here is that this was unnecessarily complex for the problem. It is easy to get blinded by the light. So I'm done from that point of view. I think we may have time for a couple of quick questions. There are no questions. It was all entirely clear. You understood everything I said. Nothing was contentious. Oh, I don't believe that for a second. OK, let's go back to this. Mixing generic and arrow styles. Come on, surely there must be something here. This shouldn't be difficult, because we're dealing with two orthogonal forms of polymorphism. That's the theory. The practice, unfortunately, is they really don't get on. In practice, we have to write layers of adaptation. This is annoying. You cannot have virtual template functions. This is very annoying. So in theory, although in principle they are actually independent, they do not mix either. They stay independent. That is quite a struggle. People often write articles and bits of libraries. Indeed, one of my contributions to the Boost library is a type that messes around with your idea of polymorphism. It's kind of, well, you know, it's a value of any kind, but yes, well, let's move that around. There are a number of techniques there. That function wrapper I showed you earlier on is another one. I invite you to look at the implementation and see how you feel afterwards. It's pretty smart. But again, if that's what it takes to mix, you have to be very careful. So it can be challenging. In practice, I've found you can actually do this. But you end up with a layering. And you reduce the amount of adaptation, but you end up with a layering. I have found that objects in the large and generics in the small, that works very, very nicely for me. If I use standard dependency management techniques, kind of Lakos and Robert Martin type stuff, then I find that I create myself a useful space where the generic programming just flows very nicely, but there's a strict separation, and there is this kind of layering. OK, is that contentious, or do you agree with that as well? Oh, come on, give me a question. Matt.
Can you give us an example of where you think that template metaprogramming is a good idea?
Yeah, OK. Not here. Can I give an example of where I think template metaprogramming is a good idea? It's difficult to know whether I'm addressing solution problems or not. One of the areas where we do find this to be useful is in selecting types and organizing types for smart pointers, for example. In other words, if I want to get a smart pointer and I would like it to have re-export some capabilities based on its type, the parameterized type that I give it, then there's no way to do that without having a compile time if. And that compile time if is going to come in the form of template metaprogramming. I've found that when I have used this, actually, I lied a little bit, actually. There is a little bit of template metaprogramming here. I can't remember exactly where it is, but that's the point. It's very discrete. I've used it to select between two types, basic trait style selection. So it's very modest usage. It's a light sprinkling. The other area, but I don't have personal experience in this one in a practical project, other than personal toy projects, is where you are using this to, as it were, select an option that you don't want to take at runtime, but you'd rather take at compile time. In other words, generate a constant of some kind. And you'd rather not have to either pull up Windows Calculator and calculate it manually and hard code it, or have the cost of running it at compile time. Again, some of these features are actually some of the issues I've just described are actually being addressed in the next C++ standard. So you won't necessarily need template metaprogramming. It's almost like a bridging solution in that sense. OK, right. Thank you very much for your time.